Now we want to start working in CoCoALib. So we want to do a little project, which might be that I want to implement an algorithm that I read in a paper, or I want to test some examples for a mathematical conjecture, or I have a new idea for writing my own algorithm for a new paper, or maybe you have just to do your homework and you have to solve some smaller problems. So today, the example we follow is my little project that I want to do today is to implement my own Buchberger algorithm inside CoCoALib. We have seen how to do it to have a prototype in Cocoa 5, and now we want to do it properly written in C++ using the facilities from CoCoALib. So we have already seen the implementation, and we effectively want to translate that code into CoCoALib. So in general, when we start working on an idea, the first thing to do is to write a sketch on paper. So the temptation is always to open Cocoa and start typing and writing the code, but usually you should do a little sketch of what you want to do on paper. Then you have to compute some easy examples by hand so that you can test what you're doing, if it does what you really think it does. So you follow the algorithm, you follow the general idea and write down the steps you do when you compute it by hand so that you can implement it in a programming language. Then you can create some more difficult examples, maybe I say by reverse engineering something that you know the answer of and you know how to construct the question that would give that answer. So see, for example, the lecture on system solving, where we created the system knowing, fixing the points we want to have as an answer from our algorithm. And then identify what are the important objects and steps in the whole picture. So going back to our examples, that is to implement MyGBasis in CoCoALib. So the design, the sketch on paper is already done. I mean, I did it for you, and we have even a prototype in Cocoa 5. So the input we want, the input we had in Cocoa 5 was an ideal, and the output was a list of ring-a-lam. These are the names of the types in Cocoa 5. And we have learned that we don't really need to care that much about the name of the types in Cocoa 5. But we have to do it in CoCoALib, because CoCoALib is C++, so that we need to declare the types every time. So first step is to know the name of the types in CoCoALib. So in CoCoALib, in Cocoa 5, all the types are all uppercase. In CoCoALib, we use lowercase if it is one word, like ideal. Or we call it camel case. That means we have the capital letter for each word in the name, like ring-a-lam. And then we use the template for vector of ring-a-lam. That is the analogous of list of ring-a-lam in Cocoa 5. And then we know the structure for computing a grammar basis in Cocoa 5 was given by the function that computes the index for the divisor, and then the function doing the remainder of the division algorithm, that was normal remainder LPP. And then we had another function which was the one computing the S polynomial of two polynomials. And then MyGBasis as the function doing the complete work using the previous ones. So the first steps on the computer, when you have your sketch, when you have identified the types you need and the main steps you need, you start creating some meaningful example, really step by step, so that you can follow and make sure that that's what you want. And then you have to pinpoint exactly which types you need. So, for example, in CoCoALib, you will need big int, big rat to have numbers or rationals, ring or ring LM or ideal, list or vector, depending on what we will see it, which properties you want in a list or in a vector. And maybe, probably, if your project is not too complex, you will not need to create new types. You will find everything you need in CoCoALib. Then you really need to understand which functions you need in details to know if they're ready in CoCoALib or not. And then make a simple prototype. We did it in CoCoA5. Then when working CoCoALib, you make a little prototype in CoCoALib so that it works and you can test it, so that it is easy, so that you can really go through the code and see that it works as you want. And then afterwards, you start optimizing the steps that you think might have a better implementation, and you work on the details and the refinements after you have the first simple prototype working and giving the right answer. So in our case, the first step is already done in CoCoA5. We have examples and we can print out all the steps so that we can compare with our new implementation in CoCoALib. So the types that we need are ring, because we had to create a ring, ring LM, the polynomials, when the elements of a polynomial ring, the ideal of polynomials, a vector of ring LM, so that we store the answer. We need to create the pairs, and we have to decide how to implement the pairs. There are pairs in C++. We will see that we will use, we will make a toy class so that we see how to create a small class. And that is for the types. So the only thing that is a bit dodgy in our construction is the pair that we have to make some decision about. The third point, the functions we need. So in reducer index, we needed the functions LPP, is divisible, and these are already in CoCoALib. In normal remainder LPP, we used LM, and we will see that this is not a function in CoCoALib, and so we will see how to get around this. And then we use the operations on polynomials, like minus, times, division, to perform actually the division and compute the remainder. And these are implemented in CoCoALib. And make a simple prototype. Well, we have an excellent prototype in CoCoA5, so we have something that we can actually copy from CoCoA4 and translate it. In principle, if you have a very good prototype in CoCoA5, you can kind of blind translate the code and it should work. It needs some practice, of course, but I mean, you don't need really to rethink of all the code, and it is almost automatic when you know how. Very important, that is my attitude and my suggestion for you when you work on paper, like you do the first sketch of the algorithm, then you you should work top down. That means you start with the big picture. I want to compute the Grosvenor basis. To compute the Grosvenor basis, I have to make a function making the main loop. What do I need to do in the main loop? I need to compute S polynomials and remainders for the division. Then I need to have a function for the S polynomial. I need to have a function for the division, but to have a function for the division, I need a function to find the reducer index. So you see, we have I have done this work for you. So I saw which are the logical blocks that we need to do the implementation. When we work on the computer, after we finish the work on the paper and we start doing the work on the computer, then we work bottom up. I mean, we start from the easiest function, like reducer index, a very easy function that just checks the divisibility of the leading power products. And then when that works, then we implement the remainder function. That is what we did in the last 2 lectures with me. Every time you make a function, you test it. So as we did it in CoCoA, we will do it also in CoCoALib. So we write a function and we make sure that it does what we expect. And then when we have done the function, we write the function calling these new functions we have just done. And again, we test at each steps all the functions. And I always suggest print, 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 use verbosity so that when something goes wrong and something will go wrong, that always happens. So you can find at what point you don't have the answer you expect, and you can find your bugs more easily. And now we stop with this very short presentation of the project, and we start working and see my xbasis.c, my gbasis.c come alive and work. And we work bottom up. Start from the easiest functions and build up to the most complex examples. Okay, just a little break.